So hi guys, welcome back to my channel. So today we are going to discuss a question maximum array that was from yesterday's Codeforces contest. So what the problem says is we are given an mm, array of integers and we need to uh, divide it in another array of integers such that the mex of that different vectors uh, creates a lexicographically maximum string. So let's say we have so for creating a lexicographically maximum string, our first priority is to get the number which is highest in which is higher in lexicographic order, that is 5 is higher than 4, 7 is higher than 2, and our second priority is to make the string as long as possible. So let's write down these things here. So our first of priority is to get the maximum number, and our second priority is to increase the length of string. Okay, so let's say we have this vector here and we need to create a vector b from it which is lexicographically maximum. So let's start finding out the max of this string starting from the index 0. So for index 0 we have only integer 2, so max would be 0, and you can read the definition of max in the question. It's very clear given there, and our second integer is also 2, so here also we have a max equal to 0. Third is 3, so again we have 0, again we have 0. Now we have encountered 0, and the only integer which is missing till this index is 1, so the max till this index would be 1, and now we have encountered 1, so the max till this index would be 5 because we have encountered 0, 1, 2, 3, and 4 already. So max would be 5, and now again max would be 5, and again it would be 5. So now we can see that we have created another vector which contains the max of this string till that index starting from the 0. So mm, what would be the optimal value we can take from this vector? Though, so the for our first priority is to get the maximum number. So maximum number in this vector is 5. So we can for the first part we can take a vector till here, or we can take the vector till here, or we can take the vector till here. So all of them will give us the maximum number as the max as 5. So now we will look at the second priority, that is we need to increase the length of the string. So if we take this whole string, then we will have our answer as 5 only and nothing after that in our string. So we need to increase the length of string. So for that what we will do, we will take the first occurrence of 5, we will take till the first occurrence of 5. So we will take this string as our first part, and we will take its max equal to 5. So this string is done here. So now we will remove these two from here, and we will copy that here below. So now we will again start finding the max till here. So starting from 0, the max would be 0 here, and from here 0 we have encountered 0, but we have not encountered what, so max would be 1. So now we will do the same thing with this array also. The maximum number we can get is 1, and this is the one and only occurrence, one and the last occurrence of 1 here. So we will have this full string in our second part. So our first answer would so our answer would contain 5 and then 1. So this would be our answer array. So we will print first its size as 2, and then we will print its values in another line. So yeah, this was the concept, and now to achieve this thing, uh, we will check if this if we have encountered a value, and if it is not present in the vector after that index, then we will break it from there. So first we encountered 0, but 0 is already present here. That means that we will have another value which is greater than 0 as our max if we go further. Same here too, same here also. Now we have encountered word, and then we will check if there is any one in this vector after that index. Yes, there is a one after that index, then we will encounter number max that is greater than 1. Now we have encountered 5 here, and now we'll check is there a number that can change this MEX value. So there is no number after that index in this vector, so this value can be changed. So it is the optimal place to break this vector from here. So yeah, this was the concept of getting the maximum number and breaking at the optimal position. So what we are doing, we are creating a we are creating a vector that will contain, so our numbers are between 0 to n, so we can just create a vector which will contain an integer instead of map. So in this last vector, we are storing the index which where the last occurrence of that value is happening. So for 0 the last occurrence is this index, for 1 the last occurrence is this index, for 2 the last occurrence is this sorry, for 0 the last occurrence is this, and for 4 the last occurrence is this, and for 3 the last occurrence is this. So these things are stored in this last vector, and then we are creating our answer vector which will create this 5 and 2 of our 5 and 1 of our answer. And then we are creating a max v vector. So what will it will contain, it will so what will it will have, so this max v vector will contain the booleans of the number that we have already encountered, that is the values we have already encountered. For example, we have a vector that contains 2, 0 and 1. So the if we are index 0, then the max we will make its value at 2 is equal to true, that is 2 is already encountered. Then when it go to 0, it will set 0 is equal to true, and when it go to 1, it will set 1 equal to true. So what it is doing, if we are at so first of all we are at 0 index, so our MEX would be 0. Now we go to index 1, and whose value is 0. So what it will do, it will now find the new max, and the optimal way to find a new max is not to iterate from starting to here and find the missing number. It is to check whether this number, whether the number greater than max is already encountered in this array or not. So when we are at first this index, so this value would be uh, so the value at 1 would be false, and our max till now would be, our max was 0. So now we will check the value is greater than 0. If it is false, then we will set that number as our MEX. So now it will go to 1, and it will check that 1 is false, then it will set our MEX value equal to 1 in that case. So yeah, this was the use of this MEXV vector. So it will first contain false, and we need to create another MEX vector after we break from somewhere. Let's say we will break from here, then we will have a brand new vector which will start from 0 and whose all values would be 0 in the initial condition. So instead of creating a new vector, what we will do, we will create a vector set of integer that is revert. That means we have changed this value in our in our max vector, and we need to revert this value. So this was the use of revert set of integers that would be used to optimize our code to revert that initial max vector to its initial value false. Otherwise it will have true somewhere or false somewhere. So for I0 to n, that is the basic for loop, we are whenever we are encountering a value, then we will put it max v is equal to true, and we will insert this value in this revert set of integers, and while max v of max equal to true, this would be until it is true, we are increasing our max element, that is until we will find a value that is equal to false. We will going to increase this value, and whenever we will encounter this as false, that is we have encountered one as false, then we are using that value in the below code. And now we are checking if the last occurrence of that max is less than I, that is now we don't have any occurrence of max after that index, then we will break from here. So now what we'll do, we will push that max value in our answer, and we will revert all the values that we have set as true. So we will revert this as false. We will revert our max value to 0 again, and we will clear this set. So finally we are what we are doing, if the last value, if this is possible that our last part has not been pushed into our vector, that is we have 2 0, and uh, our max value is 0 and 1 here. So it is also possible that we have not break this yet, that is let's say we have there is some case like that. So if our revert size is not 0, that is we still have something in the last of our array, then we will push that max value to our answer, and we will finally print our answer as the size of answer vector, that is 2, and the values of answer vector, that is 5 and 1. So yeah, this was the solution. If you are still watching, please like, share and subscribe to my video, it will help me a lot. So thank you for watching, see you in the next video.